Here we are with the Giles Ventless hood. This is actually a ventless fryer, and I'm just now starting it up. We're going to press the start here to get rid of the alarm. But what I want to talk about is the ventless hood section. Everyone seems to be a little excited about it. I think there's a little bit of a magical mystique about it, but there's really not, and that's what we want to overcome. You just don't want to see this. When you see this wash light come on with this on light, you're going to go into alarm in just a little bit. You got about 90 seconds. If this wash light stays on, you're going to get an error message here, and it's going to shut your heat off. On your larger units, larger hoods and things, they have the same system, but they shut off all the equipment underneath if they're wired correctly. Okay, so we just want to talk about the EAC filter today, how we can go ahead and troubleshoot that system. You find it all over, all of the Giles equipment. It has the ventless hood built on it, and that's what we want to discuss. So I've got this right now. I've just actually pulled the filter out so that it would go into this EAC alarm. I don't have an actual problem at this point, but we're going to talk about the problems that could come up. Again, there's that error message, ER24. Any of your ventless fryers are going to come up with that. We can silence that. And it says error, clean the EAC. Now if this, and you'll notice that all the lights have shut off, signifying that we've now killed the power to that driver board. That keeps us from damaging that driver board if someone has a bad filter and they just keep pushing it in, pushing it out, pulling it out, pushing it in. So rather than just keep on doing that, or if they just turn the power on and off to repeat it. Just like now, if I turn it off, when I turn it back on, the power comes back on. But it'll go back into alarm because that on light is still on. Removal of the EAC filter is fairly simple. We'll undo this latch, pull this out at the bottom, slide the cover up, and it'll come right off. Set it aside. Grasp the EAC filter, charcoal filter on top, EAC filter. Pull it straight out, being careful not to catch these fins. And then you can bring it right out, set it right down here on this unit or on another table. And we're going to look at it in just a second and test it. One of the most common issues that we have with the filter can be checked by using your basic ohm meter. You can put it on the sound side so that it'll go ahead and give you a signal like that when you've got continuity. And to test it, you should have it against the frame. What you want to check is you have 3 contacts on the side. These 3 contacts, the 2 outside ones, do the same purpose. They're actually applying power to the fins, the small fins. The one that we're worried about the most is the center. So if you were to touch the center, you should read it to each of these fine ionizer wires. You want to make sure you have continuity and that all of those wires are present and that they're tight. Okay? Most of the time what happens is if you look at this center contact on the back side, you'll notice there is a small copper tab that extends from it. And it goes to an aluminum bar right here, and this aluminum bar is what the wires are attached to. So if you go from the contact, copper, to aluminum to the wires, it should read like one solid lead, just like that. So if it does not see those wires from that contact, you're going to get a wash light every single time. You'll never be able to get out of the alarm. A lot of times what causes that is when these filters are cleaned, if they're cleaned in a fairly aggressive solution, then it'll attack that aluminum and copper. Aluminum and copper aren't always the best of friends, so you'll start to get corrosion in there. And you want to go in, you can take some emery cloth or something and try to clean that up and get in between there. A little emery file like you use for your fingernails works extremely well. You can just ease that in between the two and work it back and forth until you get that connection back. It's only going to be temporary. If they don't change the cleaning solution, it's going to come right back. We recommend using the simple green foam, and if you look at the videos, you find it on another video how to do that. You just foam it 5 to 10 minutes, rinse it off good with hot water, let it dry, and you're good to go. Now let's look at the filter a little closer. Lay the EAC filter flat with the smaller fins facing up and examine the fins for damage. Look for bent and touching fins and any kind of trash that may be caught in between the fins. Straighten out the fins as best you can, making sure the longer ones go into the slots of the frame and that none of the fins are touching. Turn the filter over and locate the small ionizer wires in between the larger fins. Ensure all 9 wires are intact and that they are tight. If several are loose, check the filter frame for damage that has it out of square. Locate the contact pad on the side of the filter. Check that the contacts are clean and ensure the center contact is making solid connection with the aluminum tube that the wires connect to. Without this, it will go into a wash every time. Now for those times when just cleaning the EAC filter, everything ohmed out okay and you're still having problems, check these contacts here and make sure that when you slide the filter in here, you're making a good connection. And also make sure that the level of this is not landing on one of the rivets on those contacts. We don't want to read the rivets, we want to go straight to the copper. If that's a problem, you take these screws out and you can pull this plate, they go into a little plate in the back. But pull these screws out, take this plate out and just elongate the holes a little bit so you can raise it up or down as needed to try to get it to line up so that it's just on the copper. Now to remove that little pad in there, the contact pad, you'll take this screw out, pull this cover off, and then you'll see this white insulator pad. These wires up here are actually going to your door switch here. Okay, this insulator pad, those screws that are holding the contact pad, they go right into the 4 corners. So when you run those screws out, they're threaded into this pad. This won't go very far, it stops right here. And it'll slide down a little bit, but you don't have to worry about losing it. But then you can pull that contact pad out, look at the back side, make sure where the wires hook up, that you've got a real good connection, that it looks good. You want to make sure that's nice and clean on these black and white wires, and try to remember which one was on which side. If you reverse it, it'll actually make a Gatling gun sound, which is something that we use for testing purposes, just to make sure that we're actually getting power to the filter at times. Just to give you an idea of what the filter will do if you reverse those wires, this is it. You can see that up there sparking all over and hear it. You'll get a lot of that going on. Now if you saw that same sparking in one particular spot instead of bouncing around like that, pull that filter out, look in that spot and look for damage, and you'll probably find some. Now to remove the Baffle filter, you'll reach up in and you've got some small handles here that swing down. There's a couple of them in the corners, opposite corners. Use those handles, lift up on it, let it slide down, and then drop it down and bring it right out. No fuss, no muss. Easy to do. Go to put it back in. You've got a little switch arm over here. Make sure that it goes under that little flat paddle switch arm. Then lift it up, slide it forward, it'll drop down. Land on these little pegs and then just put your handles right back up where they came from. The handles are provided so that you won't cut your fingers. So please use the handles. These edges can be somewhat sharp. We have our 110 volt transformer here. We're feeding our power in to here. We're feeding 208, 240 into this transformer. Coming out of the transformer, we're coming up with 110 volts, tying in right here to P1 and P2. Over here on this side, P3 and P4. These two are going out to our cell, out to our filter. And then this little board right here is what controls the DC output for our LEDs in the front. It also sends a signal over here to this board, which is our shutdown board. This board is the one that actually will drop your equipment out on larger hoods or just drop the heat elements out on units like this ventless fryer that I'm in now. Okay, it'll also, if you have a digital controller on the front, it'll also work this relay. This relay is what sends the signal to that controller to tell it that there's an actual issue. You'll notice on this board that we have a little jumper set right here. Go right over to the end of here. right up to the center. At the very top is 2.1 microamps. That's where we want to have that pinned at. Sometimes on the older units, you'll find them down here. Move those up to 2.1. You'll also notice on this small board right here, and it can be dislodged. You can just unplug it from the main board. There's another set of jumpers here, and it should be in this one closest to that corner of the board. Also set to 2.1. When you have that done, just plug that right back in. You should be ready to go. Again, this is your DC output right here. This is going out to your LEDs in the front, the on, wash, and check lights, and it's also triggering this right here. Now this particular unit has the 120 volt board in it. That is the one that we currently use, and that is the reason for the transformer. The transformer that we talked about earlier only takes that 208, 240, knocks it down to 120 just for this one board. Now, if this board should fail and you have to change it, you may have one of these old style boards. Now on this old style board, P1 and P2 are actually these two terminals right here. So it says same voltage. You still have a P3 and P4 here. You do not have those jumper settings, so we don't have any real control. But if you have to change out this, or if you have one of these boards that says PS240, that's a 240 volt board. Those will have to be changed out, and you will have to come back and put this transformer in order to make that work. In a lot of cases, if you do not have this set up already, one of the easiest ways to mount this is actually on the old style. There are some holes here, and you can just mount it right into the side of there, and that works fairly well. When you go to wire your transformer, you're going to get your transformer like this. The blue and the brown, those are your high voltage leads. That's going to be your 208 or 240. These two leads, we're going to tie those two together. Okay, just put a Moret or a wire nut on there. So now here's your incoming leads. On the outgoing, I always remember Halloween. So it's orange and black go together. Okay, and then they're going to go to either P1 or P2. And then yellow and red go together, and they'll go to P1, P2. Very simple hookup. If you have any problems, have any questions, 1-800-554-4537. Option 1, that's our tech service line. And Giles will be more than happy to help you out. Just give us a call. Now, oftentimes we're asked to determine just how do you know if this driver board is bad. And one thing, of course, if you're getting the LEDs on the front, then we know for sure that we're getting the output. So that part of it's okay. If you cannot get a spark, say you go ahead and you reverse these two wires here, then you're going to get that staticky sound that we saw a little bit ago, this reminiscent of a Gatling gun. If you're not seeing that on the other side, check that filter, make sure that you got continuity to those small wires, to those wires. And then when worse comes to worse, if you really want to test your output, you can take a screwdriver, make sure that it's well insulated, ground the tip of it, and when you pull it in next to P3, that wire jumping like that. You see that power jump? P3? That tells you that you're getting the high voltage output. By the way, this white wire coming from P3 is the one that should be going to those wires. So that's a real good way of testing that. If you see that this fuse up here is blown for whatever reason, go ahead and get rid of the board. There's no sense in replacing the fuse. The board has done all it's going to do, and it's gone.